So these are the special polar graphs, and if you guys remember, I said that you have to memorize what they look like. Okay, so you need to know, and I don't really think of it as a ratio of A to B. I think of it as which one is bigger. So here's the general form of most of these. They're usually written as R equals one number plus another number, and then it's cos theta, or it could be one number minus another number and sine theta. I guess I should have put plus minus for each of these. They could be pluses or minuses, it doesn't matter. So what we're comparing is not the sign of A and B, it's the size. So I don't care if it's a plus or a minus. I only care how big the numbers are. Okay, so what we'll notice is that if the size of the numbers is the same, it's a cardioid. And so that's them saying the ratio of the two numbers equals 1, so that makes sense. If the first number is less than the second number, so I guess that's the ratio being less than 1, then that's a limacon or limason or however you want to pronounce it that has a loop. All right, so you can see right here, it's got a loop in it. If the first number is bigger than the second, then it's a limacon or limason, and it could be a dimpled one, or it could be that the numbers are far enough apart that you don't really see a dimple there. Okay. Now, the thing that makes all of these symmetric to the polar axis is that all of these would have had a cos in the equation. So anytime you have one with a cos in it, then it's going to kind of go that way. I think if it has a plus, it goes to the right like this. If it had a minus, it would have flipped over and gone to the left. But we'll graph a couple and make sure. Okay. So all of these need to graph 2 pi to be able to see them. So go through and just mark on all of those. Those are all 2 pi. Okay. Going from 0 to 2 pi is pretty typical to be able to see all of the graph. All right. Okay. Then we're going to go ahead. Actually, let's mark this. If it says cos theta, that's the polar axis. If it's sine theta, we say it's the vertical axis. And so, like this one, if it had a sign in the equation, it would be kind of like rotated, and it would be like going up and the loop would be underneath, or vice versa. Maybe it would be going down and the loop would be on top. Okay, and again, we can play around with that. I can show you some. Okay, the rose curves are pretty interesting. So these ones, if you see in the equation that the r is isolated and the theta has a number in front of it, that's how you form a rose. If the number in front of it is odd, then you have that exact number of petals. So if you guys can see, this has 3 petals. The number in front of theta would have been a 3. Okay? And these only need to graph from 0 to pi to see the entire picture. When you graph from 0 to 2 pi, it actually does all of the petals first. It goes through and it does first petal, second petal, third petal, and then it goes back over the first petal, back over the second petal, back over the third petal. So it just hits them twice if you do 0 to 2 pi. Okay. For these ones, anytime you have double the number of petals, or an even number, you have double the number of petals. So this would have had a 4 theta, and that's what makes it have 8 petals. Right, this one has a 4 theta, and that's what makes it have 8 petals. Okay, and this one is a 2 pi. So this one has 5 petals, that means it would have had a 5 in front of the theta, and this has a period of 0 to pi. This one has 4 petals, so it must have had a 2 in front of the theta, and this one would have been 2 pi. Okay. And then these ones are unique because they have that r squared in the front, so we can recognize those pretty easily. If it's a sine, you don't really have a line of symmetry. This is kind of like the line y equals x, except we're talking in terms of polar, not in terms of rectangular, so I would not write that because that'd be weird, all right? So, but this one is going to have that line of symmetry along the polar axis, okay? It's just that this one doesn't, it has symmetry, but we don't write it like that. I guess you could say this one has symmetry over theta equals pi fourths. Does that make sense? If I think theta equals pi fourths, that would go like this. And that's where the symmetry is. Y equals x we wouldn't do because that's in terms of rectangular and we're talking polar. Does that make sense? So in our heads, y equals x is fine, but that would be like telling somebody who speaks only Spanish, like, oh, this French thing is how you understand it. And you're like, well, that's kind of weird because I speak Spanish. You know what I'm saying? So we're not going to mix polar and rectangular in that situation. But here, so I'm referencing that because if you look at the assignment asks you to write the name for each one, then to write the axis of symmetry. And so anytime you have a lemniscate and it's got a sign, you can just say that it does have an axis of symmetry, but we don't have to write if it's vertical or polar because technically it's neither of them. Okay. So we talked about that, what makes it polar, what makes it vertical. These ones are also 2 pi. Okay, so in your notes I said that there's a few things that you have to memorize. One thing is you should be able to look at the picture and say what the name is. Okay? Or you should be able to look at the equation and say what the name is. Okay? Picture or equation, you need to know what the name is. Okay? Another thing you need to know is which ones are pi and which ones are 2 pi. That has to be memorized. That's not hard to memorize. Everything is 2 pi except for a rose that has an odd number in front of theta. And that's pi. Okay? And then what did I say you have to memorize last? Oh, yes, the number of petals. Okay? So if it's odd, if it's got an odd coefficient for theta, it's that number. If it's got an even coefficient, then you double it. Okay? Yes. So that's the part. Well, the numbers, it doesn't seem to be as big of a deal, but that's part of you memorizing the names. So you have to know which one's bigger that would make it a cardioid versus a limacon with a loop or without a loop. Okay? All right, so go ahead and look at the front of the worksheet down at this part. So for the first one, we have A is smaller than B. So what does that tell us? It's going to be a limacon with a loop. And we're going to go ahead and graph this on our calculator just so you can see. So go ahead and grab a calculator if you don't have one already. And what we're going to do is we're going to hit the mode button. Thank you. We're going to hit the mode button. We want this to be in radians because in calculus we always work in radians. And we're going to turn this into polar. So right now you're probably in the function mode. We're going to go over. So the first one, if you go over, is parametric, and then the next one is polar. We're going to press enter so it's dark on that. And what you'll notice now is that instead of asking for y equals, it says r equals. And then we'll go ahead and type this in, 3 minus 4 cos, and when you hit the X button, it's going to put a theta in there instead. Okay, before we graph it, we're going to go to the window. And when we graph these, if it's most of them, we're going to do from 0 to 2 pi. But if it was a rose with an odd number in front of theta, then we could just do 0 to pi. Okay? So 0, 2 pi, as soon as you type 2 pi, it makes it a decimal. Now the step tells you if you have a more exact step, like, that's the wrong word. If you use a smaller number for the step, it takes a little bit longer to graph it, but it will give you a smoother curve. If you do like pi for the step, then it's going to be a very pixelated picture. It's not going to be a smooth curve, okay? So I typically do, I don't know what this 0.13 is, but like pi tenths or pi twelfths or something like that. It takes a little bit longer to graph, but it makes it easier to see what's happening as it's formed, okay? As far as the X-min and the X-max, this is not because we're graphing it in rectangular. It's your screen saying, like, how far left and right should I go from the polar axis, or from the pole, I guess, of the graph, so that you can actually see the whole picture. So we can go ahead and graph it and see how much we can see right now. You can actually see all of it. So because this is cos, it goes left and right, and because it's a negative, it goes towards the left. If you hit the y equals and change that to a plus, you can see that it switches it and makes it go right. Okay? If you change it again and make it sine, it makes it so it goes up. Okay? It's not actually getting wider. That's because of the dimensions of my screen. Okay? Or if I change it and make it a minus now, it's going to make it go down. Okay? All right. What is the next one? Limacon, no loop. I wrote Lyman. No, you can just say Limacon. Yeah. So if we go ahead and graph this one, we're going to have a 2 plus 1 sine theta. It's going to make it a bit smaller. This one, I think technically it would have a little bit of a dimple there, but it looks like it's pretty flat.
Please tell me Limacon comes from lima bean.
I feel like it's like lima bean, but I'm not sure. I think that it's possible that this actually comes from Latin, and maybe the Latin root word is like lima bean, limacon, and that's where, you know what I'm saying? Like, I would be surprised if there wasn't a relationship there, just because it is similar looking to a lima bean when they're kind of dimpled like that. Yeah. All right. And then we can go ahead and look at this one. So this does not match any of the special polar graphs, so we have to look back in our notes and compare it to some of the other recognizable equations. Can anyone figure out what this one is? It's not a straight line. It's one of the conics. It's a parabola. My answer key said ellipse at first, but my answer key was wrong at first. So it is a parabola. Why is it a parabola? They're the same number, yeah. So 2 divided by 1 plus cos.
This one started dying.
Oh, like dying? Okay, so if you look on here, I can't see, actually that's the parabola, right? I can see most of it, so. Sideways parabola, which makes sense, right? Because it's cos, so it should be going along the polar axis. I bet if we change this to a negative, it would go the other way. Aha! Or if I change it to a sine, are you guys excited about this or no? Yeah. We're getting bored with it? It's going up now. That's fun. All right, so this is a parabola. All right. Now this one, I don't like ones like this because I feel like this doesn't happen very often. The trick here is this considered to be even or odd? I don't know because it's a fraction. I think that it actually, so I guess the way that we can figure this out is by determining how many petals it has. So if we do 3, nope, 3 x divided by 2.
That's 3 petals, so that's not a pretty flower.
That's not a pretty flower. Oh, so let's go ahead and change. So what's happening is it's not graphing the whole thing because the period is 0 to 2 pi. So it's doing 0 to 2 pi and stopping even though you're not done. So if we change this to 3 pi, we'll get to see a little bit more of the picture. See that? But it's still not done. So if we change it to 0 to 4 pi, then it finishes. Do you guys see that? So 6 petals. So apparently 3/2 is considered to be an even number because it doubled the number of petals.
Actually, I don't think it. I think the petals are overlapping. which doesn't happen in the other ones. And I think that's
They overlap. They overlap in the odd, which is why it goes from 0 to pi.
right, which is why it's between the two. Because
Oh, you mean because the petals are literally they're like kind of crossing each other. I'd agree with that.
so they're all going to
It's
be even.
it's a mixture between even and odd,
Yeah.
which makes sense because it's a 3 and a 2.
Yeah.
Okay. All right. So that one's kind of weird. We'll say that one's ambiguous. But if you look at the back side, I made it very clear there's no fractions here. Okay. So we're going to look at this because later this unit, we're going to start to take these special graphs and we're going to be finding areas inside of them and areas of the inner loop and areas not of everything but the inner loop and stuff like that. And so it's going to be important for us to memorize these names so that when we see the equation, we can think in our head that's what it should be looking like. Does that make sense? Okay. I don't know. No. Okay. So here are the things that I wrote at the top of my paper just to get it in my memory. I wrote cos theta means that it's on the polar axis. I wrote that sine theta was the vertical axis. I wrote that r is a plus or minus b and that this would be cos or sine, that it doesn't really matter. I wrote that if these two numbers are equal, then it's a cardioid. I wrote if A is less than B, then it's a limacon with a loop. I didn't mean to write slash loop. I meant to write with a loop, but you know what I'm saying. If A is greater than B, then it's just a limacon. If there's a number in front of theta, then it's a rose. If n is odd, then that's the number of petals. And the period is pi, 0 to pi. If n equals even, then it's 2 times the number of petals. And it's 2 pi. And then the last thing is that if it's r squared, then it's a lemniscate. I don't know if I'm pronouncing those right, so when you go to college, don't say it out loud until you hear someone else say it out loud, okay? That's a good idea. Don't be smart. Don't be smart. Be stupid like the rest of us. Wait till college, they'll figure it out. All right, so those are all like the little hints I had on my paper before I went through all the problems. Okay? So this is the part of what I was saying in your homework video about maybe make some flashcards for these because these are true, like, just rote memorization. And they really will make your life easier if you're not struggling with this part. Am I saying it right? Lemniscate? What about limacon? I'm pretty sure it's
You have to
limacon.
get the special O.
Yeah, it has. Is it the O that has the accent?
Oh,
Or is
the
it?
C.
It's the C? Yeah. I don't even know how to write a C like that.
It's like facade. So the
But is it just like a sideways U underneath, or does it connect to it?
limacon?
It looks like a 5
Is it limacon?
I think so because of facade. That has that
Limacon? Limacon? Is that how they're saying it?
I like limacon better.
Limacon? I like limacon.
Limacon is so
Limacon is such a harsh sound. Like, I'm a stupid American. Limacon.
exactly.
Like, you limacon head?
It sounds like the Lima Bean troop of the Decepticons.
Yeah. Yeah.
We're gonna go all the way back to the.
Or the name of a
manufacturers.
band. The Limacons.
Oh, that is a better one. I like that one more.
Thank you. I appreciate that.